So we're looking at the total profit in thousands of dollars from a sale of X thousand units of a new product is given by this particular profit function. Okay. And remember, you notice our domain is from 0 to 10, so that's our domain. We want to find the number of units that should be sold in order to maximize the total profit. And then B, we actually want to know what is the maximum profit. So of course, if we're looking to maximize or minimize, we're going to have to find the derivative. So I'm looking at the derivative of this ln function. So it's a log, a natural log, and it's a log of a function. So you would have to do the derivative on top divided by the function itself. So g prime of x over g of x, if you remember your rules of doing a derivative of an ln. So the derivative of the top is negative 3x squared plus 6x plus 144 divided by the function, which is negative x cubed plus 3x squared plus 144x plus 1. Now at this point, remember, we set it equal to 0 because that will let us know where our horizontal tangent lines are, which would give us the max or mins depending on what we're looking for. Now remember, when we set a rational expression, and you may or may not as far as your algebra skills, when we set this equal to 0, I'm actually going to do cross multiplication. So let me write this out. So I'm looking at 0 over 1. So when I cross multiply, you notice the denominator is times 0, so it really cancels out. So I end up having negative 3x squared plus 6x plus 144 equals 0. And so I'm going to factor. We need to solve it for x, so I'm going to factor this quadratic. We're going to factor our quadratic. So I can factor a negative 3. So that leaves me with x squared minus 2x minus 48. And that all equals 0. Divide both sides by negative 3, and that leaves me with x squared minus 2x minus 48 equals 0. And this is factorable. So I know I have x and x, and since my the sign of the last term is negative, I know I have to have one of each. And I can get 48 several different ways, but there's only one way that will give me negative 2, and that would be a negative 8 times, or negative 8 plus 6. That would give me my negative 2. So I'm looking at x equals 8 and x equals negative 6. Now I'm not really concerned with the negative 6 because that's not within my domain. Remember, our domain was between 0 and 10. So I'm not even going to use the negative 6 because it's not within my domain. So my critical value is just 8. So I need to check between 0 and 8 and 8 and 10. Again, that's my domain that we're looking at. I'm going to use a test value of 0. And you take 0 and plug it back into your derivative. And when you do that, you end up with 144, which is positive, because that means my original function is increasing on this interval. And then I'm going to go ahead and plug 10 in as my second test value. And then when you plug 10 in, you end up getting a negative value, which means it is decreasing. So I'm going to have a maximum value at 8. Now, what does that mean? So at x equals 8. Now, remember, this is in thousands of units, so it would be 8,000 units. So that would be the number of units that should be sold in order to maximize profit. And then the B part wants to know, what's the maximum profit? Well, we know that x is 8, so that's my critical value. I'm going to plug that back into the original function and find out what is the maximum value. So that would be, you would plug that back into your ln, which is your original function, and determine, okay, what is the actual maximum value that is located where x is 8. And when you plug this in, you end up getting 6.72503 33642. So that's all my digits on my calculator as I calculated. Now remember, this is in thousands of dollars, so I'm going to multiply this by 1,000. So that's going to give me 6725. So the maximum profit that we're looking for, or that we'll find when we sell 8,000 units, is $6,725.